All right, welcome everybody to section 5.2. This is our properties of parabolas, which means we are going to learn how to graph. So you notice down here we're going to graph quadratic functions, and we're going to be finding minimums and maximums for a quadratic function. So let's go ahead and see what we're going to do here. So there are two different types of quadratic functions that we can graph. The first one being when there is no bx term or there's no linear term in the quadratic function. If there's no linear term, this is actually the easier function to graph, in my opinion. And it has an axis of symmetry on the y-axis, which means it's going to be just a parabola of some sort where the vertex is on the y-axis. And what this ends up being is the vertex is the same thing as the y-intercept on this graph. And the vertex of this form is 0, c. So we get that value of c as our vertex. So if we were to look at this function 2x squared minus 3, first thing that it tells us is that our vertex is 0, -3. So if we were to graph that dot, let's put some numbers on here. -1, -2, -3. And if we were to plot that point, we would get 0, -3 is our vertex of our parabola. From there, in these particular cases, what we need to do is we need to make a table of values on one side of the vertex. So you'll recall that a parabola has a line of symmetry. So if we find values on the right side of the parabola, we can mirror those points to the left side of the parabola. So that's what we're going to do here. We are going to create a table. And I'm just going to do this up here where I have a little extra room. And I'm going to find values of x. I'm going to choose values of x to find values of y. Now, you will not always have to do the table of values, but for right now, this is really the best way for us to learn how to do this. So we're not going to do 4 either. We're just going to do 2, I think. So we're going to do x is 1 and when x is 2. If I substitute x equals 1 into my equation, I get 2 times 1 squared minus 3. 2 times 1 squared is just 2. Minus 3 is a -1. So that tells me I have a y value of -1. And likewise, I'm going to plug in 2 for my x value. And I get 2 squared, which is 4, times 2, which is 8, minus 3, which is a 5. So I'm going to have to go up to a 5 here. And I'm also going to have to go negative. All right, so I have 2 coordinates. But if I have 2 coordinates, it means I actually have 4 coordinates, because these have mirror images. So let's go ahead and take a look at what this is going to look like here. The coordinate 1, -1 is right there. And the coordinate 2, 5 is way up here. And this should make sense. A quadratic grows very quickly as the x gets bigger. Now, we have mirror images to these points. Notice I went right 1 up 2. Here I'm going to go left 1 up 2. Or you think about the mirror image across the axis of symmetry, which is through the vertex. Likewise, I'm up here at 5. I'm right 2, so I have to go left 2. Now this is kind of a skinny parabola because of the 2, kind of stretches it out. And we're going to do our best to draw a nice smooth curve. And I don't do a very good job with this pen, but you will do much better, I'm sure. Okay, so notice there are no straight lines. This should not come down to a corner. This should actually be a smooth curve right there. As smooth as you can possibly get it. And there we have our graph. I didn't mention what we were doing here, I guess, on the side here. So we were going to make a table. We're going to plot the created points, the ones that you created or ones you calculated, and their corresponding points, which was their mirror image. And then you sketch the curve. So what would happen? Oops, that's not supposed to say cube. We don't know how to graph cubic functions yet. That should say a 2. Sorry about that. And let's see. If we were to graph this function, 5 plus 3x squared, so we need to figure out what is our vertex. So our vertex is the coordinate 0, comma, what? Well, this is not in standard form, so we like to put things in standard form. It's going to help some of us out. This becomes 3x squared plus 5, which means my constant term, my c value is 5, and my a value is 3. So my vertex is at the point 0, comma, 5. So I'm going to go up to 5 up here. 2, 3, 4, 5. And I'm going to plot my vertex. After finding my vertex, I need to set up a table of values. And again, I'm just going to use the value for 1 and possibly 2. I know in this particular case that the 2 value is going to be so big that I'm probably not going to use it on my graph. So let's use x equals 1 and x equals 2 just to see what we get here. If I plug in x equals 1, I get 3 times 1 squared plus 5. 3 times 1 squared is 3, plus 5 is 8. And then if I plug in 2, I get 3 times 2 squared, which is 12, plus 5, which is 17. So I get the values 8 and 17 for my y values. So we're going to see what we can fit on here. So that's 5, 6, 7, 8. All right, so I'm not going to be able to fit it on my graph, but you should be able to fit these graphs or these coordinates on your graph when we use graph paper later on. All right, so at the point 1, x equals 1, I'm at 8. Oops, that's 7. At 8. And at negative 1, because of the reflection, at negative 1, I'm also at 8. And we're going to go ahead and connect these because we know it's a parabola shape. And we know it's going to be way up here at 17 somewhere when x is 2. And there we have the graph of 5 plus 3x squared. All right, so that is the graphing for a function or a quadratic function with no linear term. So let's go ahead and take a look at what happens if there is a linear term. So this is a full standard form graph or parabola, quadratic, whatever word you want to use there. We need to make some notes first. These are super, super important on how to graph a quadratic in full standard form. So first off, if a is bigger than 0, the parabola opens up. And so what I mean by opening up is the very obvious, it's a U up, it's a smiley face graph. If a is less than 0, the parabola opens down. So this would be a downwards parabola. Notice here your vertex would be at the bottom, and notice here your vertex would be at the top. We're going to use that later. All right, the axis of symmetry is the line x equals the opposite of b over 2a. Now, this is a very, very important number, the opposite of b over 2a. We are going to use this number quite often today and often later on in the chapter. The x-coordinate of that vertex obviously goes through that, or that line of symmetry goes to the vertex. So the x-coordinate of my vertex is x equals, or the opposite of b, over 2a. So if we start writing a vertex, we're going to fill in the vertex here. So the x-coordinate is the opposite of b all over 2a, comma. Well, the y-coordinate has to come from the x-coordinate. So we need to plug that value in to our function. So if we were to call this function f of x, or whatever function we have here, the y-coordinate is the value of y when x is the opposite of b over 2a. Or what happens, in other words, what happens when we plug it in. So the vertex is f of the opposite of b over 2a. So here we get an x value that is super important, whatever number that's going to be. Let's say it's 7. We would plug 7 into the equation to get the y value of our vertex. And then the y-intercept, as always, is when the x value equals 0. And if we plug in x for 0, or 0 for x, this goes to 0, this is 0, and we're just left with a c value. So the y-intercept of a parabola is 0, c from the original function. All right, so that being said, let's take a look at a couple of examples on how to graph. First example, we want to graph x squared minus 2x minus 3. So we need to find the vertex. Well, we know what the vertex is supposed to look like from the last page. The vertex has to be the opposite of b over 2a, comma, f of the opposite of b over 2a. So in this particular case, you need to remember what is a. So in this case, a is 1. B is the number in front of the x, which is a negative 2. And C is negative 3. All right. If I do the opposite of B, so negative, okay, B is negative 2, all over 2 times 1. Well, negative negative makes a positive, and then 2 divided by 2 is a positive 1. So the x-coordinate is 1. And then the y-coordinate is what happens when I plug it in. So I get 1 squared minus 2 times 1 minus 3. And 1 minus 2 minus 3 is negative 4. All right, so let's put some things on our graph. So we need to go to positive 1, and we need to go all the way down to negative 4. All right, so plotting our vertex, it's 1, negative 4, so we're right here. And then we need to do the same thing that we did. Actually, what we should do is find our y-intercept, but we're going to find that anyway. The y-intercept is when we get 0 for x, and our y-intercept, int, darn pen anyway. All right, y-intercept is 0, comma, c, and in this case, c is negative 3. So we get 0, negative 3. Well, if we have 0, negative 3, we have its mirror image on the other side of the vertex. Its mirror image here is going to be 2, negative 3. And let's go ahead and find a quick coordinate here, quick table. If I said x and y, and I said, we already said x is 0 gets us negative 3. We already know what happens when x is 2. What happens when x is 3? So we plug in 3. We get 3 squared minus 2 times 3 minus 3. 3 squared is 9. minus 6 minus 3, which is equal to 0. So we get the point up here that is 3, 0. And we get its mirror image. We're going 2 units to the vertex, so we have to go 2 units to its mirror. And there we go. We have our quadratic function. We have our parabola, as good as I can possibly do. And drawing a parabola will obviously take some work on how to draw it well. All right, let's try one more here. Notice here we have a negative quadratic. So in this case, we should know that it's going to open down. We know it's going to be that type of parabola. And I'm just going to make a note, and you can do this every time if you so choose to do so. A is -1. B is 4. And C is 2. All right, so let's find our vertex. Our vertex is x equals the opposite of b, which is 4, over 2a, which is -1. And if we simplified this, 4 divided by -2 is -2, but the negative makes it +2. So our vertex starts at x equals 2. And we need to plug that value in. So we get negative quantity 2 squared plus 4 times 2 plus 2. So here we get 2 squared, which is 4, but the negative makes it -4, plus 8 plus 2, and -4 plus 8 is 4, plus 2 is 6. So our vertex is at the point 2, 6. So we come over here, and we go ahead and plot some points, or our first point anyway. 1, 2, 3, 4, 5, 6. So we're at the point 2, 6. We know it's a downward parabola, so that's okay to be way up here on the top of our graph. All right, let's go ahead and set up a table for x and for y. And we know when x is 0, we know that that's the y-intercept. And when x is 0, we get a 2. And if we go 0, we know what's out actually that's there. We can actually figure out what the point is at x equals 1 as well. And we go -1 squared plus 4 times 1 plus 2. And -1 squared is a -1 plus 4 plus 2, and -1 plus 4 is 3, plus 2 is a 5. So that means we get a 5 right here. All right, so that actually gives us enough data to plot our other coordinates, and we get the point 0, 2. And then we get its reflection way over here at 4. And we get the point 1, 5. And we get its reflection over here. And look at there, we have the coordinates now necessary for a downwards parabola. And that was pretty bad drawing, but you get the idea. All right, last piece that I'm going to talk about is the minimum and maximum values. And the minimums or maximums occur at the vertex of a parabola. And that should be obvious if you are thinking about a parabola that looks like this. This parabola has a minimum value, meaning the smallest value or the lowest value on the graph. And this parabola has a maximum value. And those max and min values occur at the vertex. So if we make a note here, the min or max value is the y value of the vertex. And that's the smallest y value or the largest y value that you're allowed. If a is bigger than 0, then the parabola has a minimum. And if a is less than 0, then the parabola has a maximum. And that's like what's going on up here. So if a is greater than 0, that's this type. And if a is less than 0, that's that type. Let's do a quick example so we can move forward and get working on our examples from our textbook. All right, so we have this. We want to state whether it has a minimum or a maximum, and we want to find it. So in this case, a is bigger than 0 because it's a 3, and that means that this has a maximum. So I know that it has a max at y equals, I don't know yet. Since it happens at the vertex, we have to do the opposite of b divided by 2a. In this case, we're going to get the opposite of 12 all over 3 times, oh, sorry, that's your a, times 2. So 12 divided by 6 is 2, so it's negative 2. And since we're looking for the y value, we need to plug in negative 2. So we get 3 times negative 2 squared plus 12 times negative 2 plus 8, which is going to equal negative 2 squared is 4. 3 times 4 is 12. 2 times negative 2 is a negative 24 plus 8. And if I did 12 plus 8, that's 20. Minus 24 is a negative 4. So the minimum, oh, shucks, I said maximum. Sorry. That is not true. Man, bad, Mr. Nelson. All right, this has a minimum at y equals negative 4, right? Because when a is less or greater than 0, it has a minimum. All right. So there we go. We have all that we need to know for this section. Again, I hope you learned a little bit, and I will see you guys later.